All right. Well, hello, students. Today we are in our Algebra 1 note packet, okay? And we are in notes N1-11. If you notice, we don't have very much more in this packet. So just keep in mind when we get to the end of a packet, it means we're finishing our unit and we are about to take a test. So get ready for your first Algebra 1 test in high school. All right, so what we're going to do today is we're going to do something called literal equations. If you see, I already have a little bit written in here, so if you want to go ahead and write that down, that would be awesome. So a literal equation is an equation with multiple variables, and that's what we're going to be looking at today. We're going to be looking at an equation where we're not going to see very many numbers. It's going to be mostly letters. Now, there will be some numbers, and that's okay, but it's going to be letters, okay? So what I want to do first is just review how to solve an equation. Here's a regular equation, 2x minus 5 equals 13. So our goal here is to get the x by itself. So we would say plus 5, and we would get 2x equals 13 plus 5 is 18. And then we're going to divide by the 2. Divide by 2, and we get x equals 9. Well, in a literal equation, there's going to be so many letters that we're not going to get x equal to just some number. What's going to happen are we're going to have letters in our answer. But if you look, the b is in the same place as the 5, and the a is in the same place as the 2. So we're going to do the same exact steps, just with letters instead of numbers. So the first thing that we want to do is get rid of that minus b. So we would say plus b. We're going to add b to both sides, and you get ax. Again, these b's cancel just like normal, equals. Now, we can't really add c plus b, so what we have to do is write it as an expression. We're going to leave it as a math problem. So this is just going to be c plus b. You see how I did that? I didn't actually add them because I can't add a c and a b, but I can write c plus b. All right, now we want to divide by our a, just like we divided by our 2 over here. So we're going to divide by a, divide by a. Well, now because we don't know the values of these letters, we can't actually do that division. What happens is x is left in terms of these letters, which means those letters are still in the number. So our answer is x equals c plus b all over. Remember, this fraction bar means divided by, so divided by a. And this would be our answer, and that's what a literal equation does. It leaves our answers in terms of different variables. All right, so if you look here and where it says quick write, I went ahead and did this for you before we started our notes today. So it says identify similarities and difference between the two equations. It says, and I said they both use opposite operations to isolate. This word isolate means just to get the letter that you want by itself, to isolate it, get it on its own. All right. And then the difference would be the literal equation doesn't simplify nicely. So nicely means how we got x equals 9. That's pretty nice. Over here, x equals c plus b over a. That's not very nice, right? And that's because of multiple letters. All right. So as we go through this today, I know this is going to kind of blow some of your minds, and that's okay. What I want you to do is just go slow. I want you to try each one and to do your very best, and that's all I can ask from you, okay? So if we look at number 1, on our one-step problems, it says solve for W. So W is what we're trying to get by itself. So what we have to look at is what's going on in this problem. I have A equals LW. Do you know what it means when L is written next to W? LW just means L times W. So what we have to do is figure out what is the opposite going on between L and W. Well, if it's being L times W, what we have to do is go ahead and divide by L, because what I want to do is get the W by itself. So when we want to move stuff to the other side of the equal sign, we do the opposite. So L, whenever I divide on this side, I also have to divide on this side. These L's cancel out, so I'm left with A divided by L equals W. And you look, and it looks like we have W by itself. So we're done. We've got W. We've solved for W. All right, now we're looking at number 2. Number 2, it looks like we're going to solve for T. Okay. Now, when we solve for T, you have to pay attention to what's going on. P times R times T, and we want to get T by itself. So if these are being multiplied by P and R, what I can do is I can divide by P and R at the same time. Okay, so I'm going to divide I by P and R. So on the left, I'm left with I divided by PR. And on the right, the PR cancels out. And all I'm left with is that T that I wanted to get by itself in the beginning. All right, let's look at number 3. Number 3 again says solve for x. So I have to figure out what is happening to x. Well, xm means x times m. So I want to do the opposite of what's happening to x. So what I'm going to do is divide by m, because the opposite of multiplication is division. I'm going to divide by m on both sides, and I get x, these m's cancel out, equals n minus p over m. Right? So we're doing the opposite of what's happening to each letter. So now if we're looking at 4, it says solve for m. So I'm going to find m in my problem. M is right over v. So we have to figure out what's happening to m. This says m fraction bar v. Remember that fraction bar means division. So this is m divided by v. Well, to move it over here, we do the opposite of divide, which is we're going to multiply by v, multiply by v. So on the left, remember when you multiply two letters, you just write those letters next to each other in alphabetical order. So V times D is just D, V equals. And on the right side, when I multiply M divided by V times V, what happens is those V's, they cancel out, and we're just left with this M. All right, so I know that some of you are thinking, like, what is going on? And that is okay. It is okay. Remember, I just want you to look at your problem, see what's happening to the letter you're solving for, and do opposite operations to get it by itself. All right. Now we're going to look at some multi-step problems. Okay, so we're not completely done with this stuff yet. So some helpful hints as we're going through these is think backwards of PEMDAS. So in PEMDAS, we do multiplication and division before we do addition and subtraction. But when we're solving any kind of equation, you want to think backwards from that. You always do addition or subtraction and then multiplication or division. Remove any fractions by multiplying by the reciprocal, and the last step is usually to divide by whatever is next to your variable. So just keep those things in mind. So now we are going to look at number 5. It says A equals 1/2 B times H. So what I want to do first is let's go ahead and get rid of that fraction. And we're going to get rid of that fraction by multiplying by the reciprocal, okay? We're just paying attention to this little helpful hint here. We're going to do that first. So to get rid of the fraction on the right side, we're going to multiply by 2 over 1. And we're going to multiply the left side by 2 over 1. Okay, well 2 over 1 is just 2. So what we're going to get when we multiply 2 times A is just 2A. Equals, well, and over here on the right side, the fraction cancels out, and we're left with the BH. All right, and our goal is to get the H by itself. So now what we have to look at what's happening to H. This is BH, which means B times H. So I have to do the opposite of multiply, which would be to divide. So we're going to divide by B, and so we're going to have 2A over B equals H. All right, let's look at number 6. Number 6 says solve for B. So we're going to look for B. If you look, B is on top of the fraction here. It's in the numerator. So before we can look how to get rid of that C, we have to look and see what's underneath that little expression there. So we have this D. What we want to do is get rid of that D. Remember, this fraction bar means to divide. So we do the opposite of divide by D, which would be to multiply by D. So we would multiply each side by D times D times D. Remember, when you multiply letters, you just write them next to each other in alphabetical order. So D times A is just A, D equals, on the left side here, these D's are going to cancel out, and we're going to be left with a B plus C. Okay, now we can look at B and we can see, well, what's happening to B? Well, it's being added, C is being added to it, so we want to get rid of C. We want to move C over to the left side. So we'll do the opposite of add C, which is to subtract C. So we'll say minus C, minus C. So remember, we really can't subtract C from AD. So what we're going to do is we're going to write it as an expression. Okay, we're just going to write it as kind of like a mathematical sentence. So this is going to be AD minus C equals B. Okay, notice how I didn't actually do any of those operations. I just wrote them like I was going to do them. All right, just a couple more. We look at number 7. It says A equals big P plus PRT. So what we're going to do is we're going to solve for T. And remember, in our when we're solving these, think of PEMDAS backwards. So we can't do the multiplication or division before we do the subtraction. So I want to get rid of this P plus PRT. So what's going to happen is I'm going to say minus P minus P. So what I'm going to have is A minus P equals big P R T. What I'm trying to do is get this little t by itself. So now I have to divide by big P and R to get the t by itself. So big P R, big P R. So I'm left with A minus P over PR equals T. And at this point, we are done with that one. All right, now we're looking at C and we're solving for F. So remember, let's get rid of that fraction first. So we're going to multiply by the reciprocal. So times 9 over 5 times 9 over 5. So 9 over 5 times C is just 9 over 5 C equals big F minus 32. So I'm trying to get the F by itself, so all I have to do is add 32 over. Now, if you look at the left side, there are no numbers or constant terms to add it to. I do have this 9/5 C, but that 9/5 is attached to that C. So I can't add anything to that unless it has a C with it. So if I can't actually do the addition, remember we just write the addition as a mathematical sentence or a problem. So we would have 9 over 5 C plus 32 equals F. And this right here would be our answer.